All right, let's try that again, folks. Welcome. Welcome to the Seagrass Seminar Series. Today we have Dr. Emma Jackson with us from Central Queensland University to talk about seagrass restoration, a topic that is very close to all our hearts, I'm sure, and should make for an interesting discussion afterwards. Just a few ground rules before we start. Please keep yourself on mute if you are not speaking or asking a question. If you do have questions, please put them in the chat so that we can call on them later as well. So without further ado, I will let Emma do a little introduction to herself and then start on her talk. Emma, over to you.
Thanks, Siti. So being based here in Australia, I'd just like to acknowledge the traditional owners on the lands in which I work, so the Baili, the Turrbal Bunda, the Gurang people, and pay my respects to elders past, present and emerging. I'd also like to say thank you to the World Seagrass Association for inviting me to speak, and also thank you to you all for coming along at your various different hours of the day and taking time to listen to me and hopefully have a bit of a discussion afterwards about some of the things that I'm going to talk about. So I'm basically going to be speaking today about the restoring seagrass resilience in a dynamic seascape. I'll try and talk for about 40 minutes, but stop me if I go over, and then leave a bit of time for having a bit of discussion afterwards. Momentary, see if it changes slides. Hey, okay, so when I was putting this talk together, I wasn't sure if it was going to be quite a broad audience, and I thought I'm going to have to explain resilience. So I thought, well, I could show the classic sort of, bowl and cup figure representing ecological resilience, or like this one from James Haddon that he's adapted from Standish, or I could actually talk through the concepts of the theoretical ecologist Holling. But I thought it might be a bit heavy to start my talk on all that, and also looking around the room, there's people that can better explain resilience than I can. So what I'm going to do is I'm going to talk about resilience using something that we all have in common at the moment, and the reason that we're really sat here listening to me talk about restoration rather than being Chesapeake Bay learning about Bob Orth's group, world leading seagrass restoration right now. So and of course that's the C word. Sorry, I'm going to talk a little bit about COVID. So really, resilience is something that we hear a lot about at the moment. We're basically hearing it across the world in relation to the COVID-19 pandemic. And the key question seems to be how we're getting affected by the social distancing, the mask wearing, the lockdowns, and the more severe impacts of the pandemic, and in terms of those that are obviously directly affected, and what state we're going to come out of the other side as. So will it be a monk, a hunk, a chunk, or a drunk? And then, of course, the question is, are we going to stay in that new state? So, or are we going to have a regime shift to a new normal? Or if we are going to come out of it and get back to how we were, are we going to do that quickly? Are we going to recover quickly? Or are we going to gradually return to our pre-COVID state? And of course, how quickly we recover or bounce back is partly due to the state that we were in before COVID pandemic, back in the magical time of 2019. And basically, what that means in terms of not just our fitness, but how we lived. So what our habitat was, what we lived, what we did in terms of our job, and any other pressures that were on us before all of this started. So then there's how COVID affected you, whether you were maybe where you were, you might have been in Peru, so it's one of the worst hit per capita, or like me in the relatively safe bubble of Queensland. Have you had prolonged lockdowns? So, or has there been like a gradual increase in restrictions, or has it been like a bit of a yo-yo in terms of the changes of what is and isn't possible? So all of those things going into this disturbance affects like how resilient we are, and affects how quickly we are able to recover and how quickly we can get back to how life was. Others will just shift, and it all depends on our resilience. An ecosystem, oh, I've just lost my slides. Hang on. Okay. So ecosystem resilience is really that inherent ability to be able to absorb different disturbances and reorganize whilst we're undergoing state changes that maintain those critical functions. And most ecosystems are adapted to resist a little bit of change and a little bit of disturbance. It's when things change from that normal range of disturbance and they start to experience other things or interactions in terms of anthropogenic and natural disturbances. And it's then that the ecosystems might cross a threshold into like a new and potentially unwanted state. So that unwanted state may be that they now can't deliver some really significant ecosystem services that seagrasses are known for and that we love them for. And this basically just, I won't go through all the different ecosystem services because I'm sure we're all aware of them, but obviously there's the habitat provision for fish, carbon sequestration, sediment stabilization, being food and resources for culturally important species, like here in Australia we have the dugong and the green turtle. So really it's that shift into something that's not delivering these functions or losing seagrass altogether. And in their framework of resilience of seagrass ecosystems, Richard Unsworth and colleagues basically summarise this quite nicely in terms of the components of a seagrass meadow that influence resilience. Can you see my mouse when I move it? I hope you can. So actions in terms of any one of these things. So we've got here, the connectivity of the ecosystem, functionally important species. So there might be species that are really inherent and symbiotic with the seagrass that are helping it to be resilient. The species diversity, the genetic diversity of it, whether there's a seed bank or not, having good water quality, all of these things, all these components are very important in terms of the health and the ability of that seagrass meadow to resist and recover from any disturbances. And really actions in terms of restoration, in terms of restoring resilience or maintaining resilience can actually be directed at any one of these particular elements, whether that's improving water quality, understanding or enhancing the connectivity, boosting seed banks, or considering genetic diversity and restoration efforts. They can all be done. And really, it's taking that holistic approach to restoration that's really going to be the key to improving the resilience. And of course, it comes down to managing the manageable. So managing things that we can predict or things that we know are anthropogenic disturbances that we can do something about, rather than, and then making it, doing those things so that it can basically resist and recover from those disturbances that we can't do anything about. It's also about identifying ecological thresholds in terms of the level of disturbance that something can take, and getting those indicators for when we're getting near to that threshold, which is still remains to be a bit of a challenge. And then monitoring those early warning signs so that you can actually intervene and do things to improve or enhance the resilience before an activity occurs, or afterwards come in to help a faster recovery when a disturbance has caused a shift in the state of a seagrass meadow. So I'm going to talk a little bit about some work that we're doing here in Gladstone. So this is where I'm based, in the Coastal Marine Ecosystems Research Centre at CQUniversity. So we're basically in this little red dot on Australia here, in the subtropics. So we're literally just below the line of the Tropic of Capricorn. It's just above us near Rockhampton. And we're in the southern part of the Great Barrier Reef World Heritage Area, where we sit within a large multi-commodity port, the Port of Gladstone, which is the 5th largest coal port in the world. It has 3 LNG plants, a couple of smelters, a lot of industrial activity going on around the place. But it's also one of those places where there's a really nice collision of industry and activity and the port operations alongside some really amazing natural habitats. So we've got beautiful mangrove forests, inshore coral reefs. We've got over 100 different seagrass meadows in the region as well. And I know there's places like this across the globe where, because seagrasses always tend to grow in those places that are most attractive to humans in terms of living. This is a particularly good example that some of you might have seen me show before. So this is a wharf, the aluminium wharf. So all those silver bars are all bars of aluminium, and they've built this wharf out into the deep water channel so that the cargo ships can come in and collect the cargo. But actually building this here has created a bit of shelter to this bay, and these dark areas that you can see is seagrass starting to grow, and it's getting really quite dense in there now. And just down at the bottom here, you might be able to see a dugong that's been feeding on this seagrass. So I think it really captures what Gladstone's like in terms of that juxtaposition of industry and really great habitats. Being in the tropics and subtropics, it's pretty dynamic, and that's reflected in the seagrass meadows, which have to resist and recover from a range of natural disturbances. So first of all, we're in cyclone country, and Gladstone's sort of near the tip. We get a lot of tail ends of cyclones rather than actual cyclones hitting shore here. And this figure here just shows the cyclone paths and categories over just 6 years within the Great Barrier Reef World Heritage Area. So being in the tropics, we also have a dry and wet season. So in the past, as you know, El Nino years have been correlated with increased chance of like drier conditions, a reduction in rainfall, and less tropical cyclones. And then in La Nina, we get wetter springs and higher numbers of tropical cyclones during the cyclone season. And these flood events that we get associated with some of these conditions can really bring down sediment from the catchment and create large plumes of turbidity, which can actually be seen from space, and again can be quite disruptive to seagrass. The number of different ports of the Great Barrier Reef, and there's also, this is often associated with an increased population density. So you can see here with the hotspots tend to be where there's larger ports. There's a lot of land reclamation that happens within these ports and coastal development. And in terms of other land use, as well as urban expansion and coastal development, there's also mining and agriculture in the area, mainly beef, cattle and sugarcane. So we've got land reclamation, nutrients coming into the system, more frequent flood events, and these all are major disturbances to the seagrass. So being in the Great Barrier Reef World Heritage Area means that there is one good thing, is that there's a fantastic amount of seagrass monitoring that occurs. It focuses mainly on ports and urban hotspots, including and includes things like the marine monitoring program, the Seagrass Watch, and also specific port-based monitoring programs that are run out of Trop Water at JCU by Michael Shee's group. So a heap of data on them, and this map here, this table that I'm showing you here is just some data that's been collected over the years by that group for Gladstone Ports Corporation, that now feeds into a report card on health of the harbour and uses seagrass as one of the indicators. So these clouds at the top are times when we've had significant storms or flood events in the regions. And then the colours, just like a normal report card, they're attached to the letters. So dark green and A is doing very good, and red and N and E is doing very poorly. And what you can see is that every time we get one of these big flood events, you get the seagrass basically suffers. And these are different meadows across the harbour. So you can see after a flood event, you get, across the harbour, you basically get almost like, impacts across the harbour. So these are quite sort of harbour scale, harbour-wide events. I said that 3 different ways then. And you can see when we have more frequent ones that this can actually persist for quite long periods of time. So this big red and orange area here. But what you can also see from this is that we get different meadows recover faster than others. So some come back to being hunks and not chunks or drunks very quickly. And others really sort of take a lot longer to recover if they come back at all. So there's some meadows in the mid-harbour which are still not really managing to recover from the events that we had back in 2015, 2013. So why the difference? Well, the first reason is that we've got lots of different species of seagrass recorded in the area. They're mainly colonizing species such as the Halophilus. So we've got Halophila ovalis, Spinulosa and Decipiens, and also Halogule uninervis. And then opportunistic species like Zostera muelleri. So they're the 5 main species that we have here in the harbour. And like I said, so these are colonizing and opportunistic species. We have a lot less of the persistent seagrass species in this region. And if we apply this to some of the work that Kieran Kilman's did on seagrass meadow types and how that can inform management of seagrasses, we're basically getting these opportunistic colonizing species in nearshore estuarine environments in the intertidal and with varying degrees of wave exposure. So we end up having some meadows that are very enduring, some meadows that are transitory, and that's underlying all of those disturbance events that are happening at a larger scale. The other thing that we see happening is that manifestation of that feedback between seagrass presence, suspended sediment and benthic light. So that important feedback that can induce bistability between 2 different ecosystem states. So one where the presence of seagrass, dense seagrass, can reduce the suspended sediment concentration, meaning that the seagrass is getting light and therefore favorably growing. versus when we lose seagrass, and that increases the turbidity because the fine sediments get resuspended, and that can therefore reduce growth in the area, but also prevent seagrass from coming back. And this is again another overlying sort of like level of complexity that we need to consider. So Matthew Adams and colleagues looked at that potential for biostability in seagrasses and identified a number of factors that we look at when we're sort of mapping what the different meadows are doing in an area. So the point basically being that if a meadow is lost and it has that higher potential for biostability, then the chance of it naturally coming back will be really low, and restoration is going to require some really large scale interventions or even habitat enhancement. For example, capping fine sediments or doing restoration at scale to be able to make a difference. Whereas the areas that are lower potential, they're the ones also that are more likely to naturally recover. So a challenge in a really highly dynamic environment is to develop a management scheme that includes restoration enhancement that can secure ecosystem functions and services that can detect and intervene before there's a state or a regime shift. So how do we manage meadows in these dynamic systems, and how do we intervene in terms of restoration? So I'm going to talk through some of the things that we're doing with these dynamic meadows, and apologies, some of you might have heard some of this before. We're also going to look at the practicalities and some of what we've been looking at, how you do this at scale. And then talk a little bit, mainly for trying to sort of get some discussion going around some of the policy barriers and some of the things that are stopping us from doing large-scale seagrass restoration, which obviously includes funding, but also touching on apathy. So how do we manage resilience and look at restoration when we have meadows that might be naturally transitory, or they might be shifting into another stable state that makes restoration difficult, or if we're in an area that there might have been seagrass, not seagrass there since the history of monitoring began, and then suddenly it becomes seagrass. So how do you make the argument for how we should be doing restoration when you've got a system like that, and do we need to be doing it? So this map on the left shows the historical and the near current distribution of seagrass in Gladstone Harbour, as well as habitat, suitable habitat that's been modelled through habitat suitability modelling to be potentially suitable for seagrass, but currently unoccupied. So it's almost like you've got the current distribution is its realised niche, and then the other areas, including the historical and the potential or its fundamental niche where it could grow. So when you're looking at restoration, there's the habitat argument where you only restore seagrass where it's historically been, i.e. its realised niche. And then there's like the human mediated or facilitated dispersal. And that's where you transplanting or putting seagrass back into an area that's within its fundamental niche, even if that's not where it's currently growing, and you're expanding that the current realized niche. And then there's novel ecosystems where you're almost like creating the niche. So you're putting an area where you're enhancing a habitat, making it suitable so that the seagrass can grow there, where it obviously didn't grow before. And back in 2006, Suzanne Bell promoted the consideration of meta-populations when looking at restoration, which captures this really nicely and is the basis of what I'm going to talk about for managing and looking at restoration in these dynamic systems. So a meta-population is a population of populations. So it's a patch of suitable habitat. So each of these populations exists on a patch of suitable habitat. So these circles that you can see here, each of which is separated from each other either by unoccupied or occupied patches of suitable habitat by some unsuitable habitat. So that's like the matrix in between. So these are like your seagrass meadows separated by deep water channels or rocky reefs, or places that are just too exposed, or the depth isn't right for growth. So something is unsuitable about the habitat. And then each one of these populations is going to have its own relatively dynamic, independent dynamic, where extinction and colonization, immigration, emigration, disturbance regimes are all very, very different. And that's going to affect its ability to become temporarily extinct or recolonize. So the long-term persistence of the entire population is therefore based on the stability of the metapopulation is basically based on a balance between a population's extinction and recolonization. So what I was saying before about that habitat argument, that's restoring the seagrass where it's historically been, so where it is at the moment. The human mediated or facilitated dispersal might be to put it into areas where it isn't currently growing, so into these like blank areas. And then a novel ecosystems approach would be to actually create new areas. So why would you create new areas, and why would you create novel ecosystems to improve resilience? So looking at metapopulation modelling and using it as the basis for some of these decisions, you really need to be asking which patches are most likely to go extinct or become colonised. And we need to know for that the scale of connectivity, which is set by the dispersal ranges of the species, the spatial distribution of suitable habitat, and the tolerance of those species. So we're basically asking where is seagrass growing, where is suitable habitat, and where is seagrass growing in that suitable habitat. So decisions, like I said before, so decisions in some areas where you've got less transitory meadows, the decisions are often made based on the past occurrences of a specific seagrass species at a specific location. And that's reliant on very robust historical data. And in tropical systems where the seagrasses can be very transient and the distribution can be highly dynamic, identifying an area where a seagrass has been permanently lost can be really difficult without long-term data. So this figure, which some others have nicknamed my Candy Crush diagram, illustrates how the presence or absence of the seagrass, so the current and historical distribution of that seagrass, can be basically looked at compared to the predicted habitat suitability maps to create a really informed like management decision framework. So this decision framework was been used to prioritize interventions, whether they're high, medium, low, or very low, in terms of both restoration, habitat enhancement, if it's going to areas where the habitat suitability is really low, the creation of meadows, if you're doing it in an area where there's no historical distribution, and to identify sites where natural recovery potential is high and intervention requirement is really low. So for example, areas where there's really suitable habitat and there's a really high propagal immigration, so it's a sink, is going to have potentially a very high potential for natural recovery, versus an area where a high priority for restoration might be an area where there was historical distribution, there's no seagrass there now, the habitat is really suitable, so you're not going to have to do any enhancement of the habitat, but there's really high potential for it being a good source of propagals for other parts of the system. So in terms of the overall resilience of the metapopulation, it's going to be really important to target those areas first. So I won't go through every single potential priority within this diagram, but just to show you that it's basically looking at it, trying to take all of those different elements together and look at a way of prioritizing where we should be doing seagrass restoration or habitat creation. So really I won't go through this in too much detail, but basically it depends on having good habitat suitability models, and these can be quite broad, like this one that we did, or you might have a really good, very in-depth habitat suitability model that looks at multiple years and has all the best data in it. So you can apply each one of those. And then this I'm not sure it's going to let me play this. Yeah, it's playing now. It's not. Okay, so this is just a dispersal model that we did quite a while ago that feeds into this. And you can see that these are the large meadows, these polygons here. And we're looking just at the intertidal dispersal of Zostrum muelleri in terms of its fragments, but we also did this for seeds. And what you can see here is that you're getting like the release of these propagules within the harbour and then moving around the harbour. And then after time, you can so I can see subtitles. Can everyone else see subtitles? I don't know why. So you can see after time, these are deposited and start to sort of move around in terms of like bed movement, which isn't very much within the harbour. So what this showed, and we ran this under various different conditions, is that there was differences in terms of where propagules are ending up within the harbour. So it became very obvious that there were areas that were important sources and potential sinks of material, and that sink and source map was basically put into our GIS analysis to look at that difference and that prioritization of where we were going to do seagrass restoration. So this just shows the create and restore outputs at low, high and medium levels, and it's just basically as an indication of the output and how you can use that to identify where you could avoid doing restoration because there's a really high potential for natural recolonization, or looking at those areas where you might need to intervene and it'll be worth doing because it's going to have a big input into the potential for the wider metapopulation. On top of that,
if you wanted to turn it off, there is a speech to text button in your presentation that I think you activated.
Did I press that?
Yeah.
I don't know where.
It's at the bottom where you would normally have like your laser pointer and all that. Yeah, you see it's like highlighted, that little white button in the green area. I don't know if you can see it.
Remote control?
I think it's like auto subtitles or something like that. Okay, maybe it's gone now. Try again.
Oh, yeah, I've got it. Yeah, okay. It's just taking a while to do. Oh, now I've put it back on. Sorry. To cut this. Right, I think it's gone now. Okay, good. Sorry, that was getting a bit annoying, wasn't it? So yeah, so I guess the thing that I wanted to show this in relation to, so the other thing that you can apply to this is then maps of that potential for bistability. So by putting that potential for bistability on, not only are you then prioritizing where you might need to do restoration, but also what that restoration might have to look like in terms of the potential for bistability. So you're going to have to do like really large scale restoration at that site because it's got high potential for bistability, or do habitat enhancement and things like that. So the thing I wanted to talk about a little bit was that that idea of putting, and this is one of the challenges in taking this sort of approach to restoration, i.e. looking at areas that are within either the fundamental niche or in areas where there hasn't been any historical record of seagrass. It's a real opportunity to create seagrass habitat. You know, doing restoration in an area where there was historical seagrass is very easy, but to try and do it in an area where it hasn't been historically recorded is a bit more challenging. It's a challenge in terms of getting the permits to create seagrass, and that's even if it is within its fundamental niche, you know, through facilitated dispersal by transplants or seeding seagrass. So the justifications for doing this are if there's limited historical data within a region, if there's going to be if you need to do modifications of natural habitat, if there's poor dispersal, which you can show through the dispersal models, or if there's permanent removal of original habitat. So land reclamation is becoming an increasing problem along our coasts everywhere in the world, and is chipping away at seagrass meadows. So without moving in the direction of creating new seagrass meadows, then seagrasses, in my opinion, are just going to continue to decline no matter what we do, or even if we have the most successful restoration or conservation methods, we're still going to keep losing seagrass. So it's that idea of moving into that you know, being able to create new seagrass meadows where there hasn't been seagrass before is going to have to be the way that in my opinion, that we have to go, and it'd be good to discuss that. Another challenge is that pathway for funding and implementing restoration. So on the land here, just like in many places here in Australia, there are conservation policies to protect the seagrass, but then there's also policies for offsetting losses when a development does go ahead. And so far, the offsets are rarely used to pay for seagrass restoration. The reasons put forward even back in 2014, but are still mainly applied today as well, are that alternate stable states, the fact that people say, oh, they're just going to come back by themselves, because in some cases they do, and that hysteresis. The fact that there's been poor restoration success, but often that's because very small scale projects that are up and going and are done without any consideration of all the things you've got to consider when you're doing seagrass restoration mean that you get poor success rate. And then the considerable effort and cost that is viewed to be associated with seagrass restoration. And then, of course, it's the slow process of showing whether your restoration was successful or not that can take years to actually show that it's worked. And I'll get onto some of the opportunities in sort of overcoming some of these issues. But the real problem is that, without large scale seagrass restoration projects, which, we know were the ones that have the most success in terms of you get more successful seagrass restoration if you increase the scale. You don't get those, then you don't have any large scale demonstration projects to show that this is an opportunity, which you need to basically be able to have that confidence to fund seagrass restoration in the first place. So it becomes a little bit of a vicious cycle. So the next challenge is how to restore seagrasses, and especially when restoring for resilience often means go big or go home. This table is just a review from a few years back of Australian restoration programs, and you can see, just move that out of the way. You can see basically the different percentages of seagrass methodologies that are used for restoration. You can see that probably the most common is those transplanting of plugs and cores, and there's all sorts of things out there, better elements and all sorts of things that you're going to attach things to put out there. Seedlings, bare root sprigs, turfs, mats, you name it, right down to just using seeds. And then the disadvantages and advantages of most of them. So obviously with transplanting and cores, it's that expense to collect, store and plant out. And then there's the damage to donors. Survival increases with size, but so does the cost. And then with seeds, obviously you've got less of a reduced damage to the donor meadow. It's easier to manage that genetic diversity, its importance in resilience. But there's also issues with seed dominant, seed herbivory, dormancy, breaking bottlenecks and collection difficulties, but also dispersal difficulties, which I'll get onto. One of those adverts. So we went through the whole process, which I won't go into detail in, but looking at utilizing plugs and all these different methods that everybody does when they're doing seagrass restoration, see which ones would work. We get really fast growth rates here. So like in the halophilas, we're getting like 1 centimeter per day, and fairly fast growth in the zostra. But we were finding that you almost needed to scale up to get over that factor that when you take cores, you're damaging a lot of the apical shoots, and a lot of the growth just starts to grow off in angle, in random directions and it does expand, but it's not really sort of like joining together very well. And the real thing though that we found with a lot of these methodologies was just the sheer difficulty in doing this at scale, which that's done seagrass restoration again has come to realize that it's very, very difficult. I'm just going to go fast through those. It's really difficult in some of the environments that we're working in. So this is a picture up in the Narrows here in Gladstone, which is a very muddy area. It's a nice seagrass meadow, but it is starting to show areas where it's in decline. Very difficult to access. The amount of damage that you would do if you went out and did transplant methods where you're actually planting things out would be really difficult. Doing them with diving and snorkeling is difficult because of currents, strong currents and crocodiles and shark activity in the area. There's also heat exhaustion factors and like I said, the trampling, the damage that you do from trampling. The other issue is not just the large expanses of areas that we've got to cover, but the fact that with this resilience and restoring for resilience, this isn't going to be a one-off thing. This is going to be a case of getting a method in place where you can go and help a seagrass to recover after an event, or look at areas that are starting to decline or not recovering and enhance them through seeding activities or enhancement to get them to be able to recover faster. So they're not going to be one-off, go there, restore the seagrass, everything's good again until it gets lost again. It's going to be a case of working in with that dynamism. So really the way to go was scaling up with seed. So we very quickly moved on to looking at seed-based restoration and working out all that information that's on the back of a seed packet. And there's lots still to do. And I think the thing with the seed-based restoration is this diagram is from Madston, which is a reply to Madston. So Madston published this table looking at the strategies, hurdles, and requirements for using native seeds for restoration in terrestrial systems, and just adapted it a little bit to look at seagrasses. The blue lines show where we've really got a good existing knowledge base for seed-based restoration. The yellow is where I've seen that there's studies out there at the moment that are currently addressing these issues, and the red is places where I think there's still a lot of research gaps to fill. So it includes things like not just looking at the genetics of, whether it's important to get seeds from certain areas, looking at trait-based seed selection, looking at protocols for large-scale native seed farming and seed collections. The hurdles include things like breaking dormancy, which is pretty well established now for Zostera, overcoming things like seed predation and pathogens attacks, and then that improper sediment placement. So getting the seeds out there in the first place is one of our biggest challenges, which I'll talk about. And then once they're there, understanding seedling emergence and seedling establishment so that you can put them there and be sure that they're actually going to survive into seedlings and carry on and grow a meadow. So we've looked into a lot of these things, and different researchers around Australia and in terms of Zostera muelleri have looked at some of these factors. And like I said, a lot of that has been established. Seagrass nurseries are now popping up everywhere, which is really great, not just for sort of like growing the plants in-house, but also for then holding flowers that can be collected out in the fields, bringing them back to lab to collect the seeds. And really, if you're scaling up seagrass restoration, this remains a challenge, is to do this at scale and have really large scale holding facilities for some of these propagules. But the challenge that I'm going to talk about differs. So we know that there's been some really successful seed-based restoration projects out there. And I just wanted to talk about one of the additional challenges that we have with looking at Zostera muelleri, and that's that the seeds are really very small. They float, well, they sink, but they basically can be moved by quite sort of like low current velocities, so they can get moved away. So if you were to try and do them through broadcast seeding from a boat, it's going to be very difficult to actually get them to stay put in the place that you're putting them out there. They also seem to show with seedling emergence that there needs to be a bit of burial, but not too much burial. And if they're on the surface, what we find happens is that as soon as they basically don't stay attached. As soon as they put up their first leaf, they'll start to be buoyant and float away. So again, it's real problems with keeping them where you want them to be. So a strange noise there. So it's really, how do you get the seeds out? And one of the things, we're looking at a few different things at the moment because this remains a challenge, but trying to get seeds out into really large areas. So looking at methods for dispersing those seeds, whether that's using groups of people. So we've got projects looking at using fishers to, recreational fishers to go and like, I'm going to pause that because it'll be noisy, to get them out there. Drone methods, we know drones are used in terrestrial systems, so there's opportunities there for utilising drones. But mainly the focus of our research at the moment is how to get the seeds to stay put and to establish. And I'm interested to hear people's other ideas on that. But whilst we still have challenges to overcome, I think, and this is demonstrated in a recent review by Niña, that we're really in a position to start to do large-scale restoration and get these large-scale demonstration sites up and running to facilitate continued increases in the amount of funding and restoration being done to offset some of our coastal developments. And there's a lot of opportunities out there. There's a lot of funding opportunities. So I was a lot of people in Australia would have been with me when we heard Scott Morrison, our Prime Minister, talk about seagrasses in the same sentence as funding. That was really exciting earlier in the year. He called them the liver of the oceans, which was interesting. But it was great to hear that they're funding these blue funding seagrass restoration and creation for blue carbon. So there's opportunities there. And really it's great that the ecosystem services that are being delivered by seagrasses are being recognised and are opening up these funding opportunities across the board. So not just with blue carbon, but with fish habitats and some of the advantages that they have in terms of capturing fine sediments and baffling currents and preventing coastal erosion. As well as offsetting carbon, the government are also obviously recognising that restoration is really good for the economy and job provision, and that training and innovation are starting now in Australia to build behind this. So we're getting a lot more in terms of some of the vocational training is starting to look a lot more at marine coastal restoration, which is really great. And there's a lot more support for co-funding of PhD students and getting this research really on the front foot. And this recognition is also leading to port and urban developers to look at how seagrass can be integrated into designs and construction, which is starting to happen here in Gladstone, which is really exciting. So this is engineering coastal development for improving seagrass colonisation and seagrass growth. So looking at different designs for breakwaters and seawalls, looking at ways in which we can utilise dredge spoil material, ways in which we can design urban areas and canal estates into areas where we can create seagrass nurseries. And then also this like ecosystem connectivity restoration, so starting to open up areas to let saltwater and come back into regions, and this can have knock-on effects in terms of creating seagrass. And lastly, I wanted to land on a bit of a high, because I think that the real reason why seagrass is now in the public eye and that things are really starting to move forward is that researchers and resource managers, like all of you out there, all the people that are working on seagrasses, have just been really engaging the public and really getting the messages out there. And engagement goals for restoration and doing engaged restoration is really quite important, not just in terms of getting volunteers and recruiting people for citizen science programs to get involved in some of the collection techniques, but that overcoming of public apathy for seagrass is we're now seeing that that's really had an effect. There's also the social license to operate, which is really important for getting industries behind some of the funding for some of these seagrass restoration projects, and a wider acceptance for those future restoration activities, bringing people along the journey so that they understand why things are, but also are not working, is really important to then sort of feed into doing things again if things don't work out, and getting that revenue basically for future activities. It's also important, obviously, for the requirement of permits. So we've been doing quite a lot in the engagement sphere, basically because of that, and doing things like gameplay for getting kids involved in it, going to schools, working with art installations, and then getting the sheer volume of seeds that we need to do these large-scale restorations. It's again interested to hear people's thoughts on how you can do this at a large scale. At the moment, though, our best bet is to actually get teams of people out there collecting the flowers like they do across the world, to get those flowers, to get the seeds in the numbers that we need for large-scale restoration. And to do that, we really need funding for citizen science programs that is starting to come through now, and they're highly successful. I'm going to leave it there because I think I've sort of put across a few questions and requests for ideas and things like that, and hopefully start a little bit of a discussion on some of these topics. The main thing I wanted to really discuss is that idea of creating seagrass in areas where it's not been recorded before, and get people's thoughts on that. But I'll leave it there. I just want to thank all the different people that contribute, because I work with a lot of different organisations and people share their data, and it's a really good community to be working in to try and get some of this work going forwards. Thank you.
Thank you, Emma. That was actually really great. And I was trying to think about seagrass restoration from a less traditional perspective, because I think in the past it's always been focused on restoration methods and etc. So this more holistic approach is actually a very exciting one. Looking at the resilience point of view. I'll open the floor up for questions. I think there are two that came through. There was one earlier on from Claudia, and I think she wanted to know what programs you use to run the simulations on, I think it was the habitat suitability.
Was it habitat suitability, or was it the so it was for the dispersal modeling we used 2Flow, and we used it as a 3D. So I worked with coastal modelers to do that, because that's not my area of expertise. And then for the habitat suitability models, we did fairly like straightforward ones, quite broad scale habitat suitability models, just using Maxent and looking at the probability of seagrass growing in areas based on existing distributions and different layers. Really, it's as you can make it as detailed as you can, and with what information you've got available. And often, it's limited just by the layers that you've got.
It was on proper yield dispersal, so I think that was FeeFlow, was it?
2Flow.
2Flow.
Yeah.
Okay.
Yeah.
All right. And we have a question from Rod Connolly. He says, in general, are we up for a harder task in tropical waters because the seeding is spread over such a long season?
Yeah, so our flowering here in Gladstone started, well, this year it started in end of July, and it'll go through, we've seen it sort of start to peter out around December. So it's quite a long period of flowering, and we're starting to get like first seed probably in like end of August through to sort of end of January. I think that can be a benefit that we've got such a large spread of like the seed availability, because it means that we've got more chance to collect more seeds. The problem that we have is in the storage of those seeds, because we're looking into some methods, and we can manage to store them without too much effect on viability for about 4 to 5 months. But basically getting them out there, if you have a longer period for collecting them, then that expands the amount of time that you can keep them for, and allows you to then pick when are the best times to put them out, which again is another challenge. Do we put them out so that they establish before we get big storm events and the wet season, or do you wait until after the wet season and put them out there ready germinated or not ready to go? So I think it can be a blessing and a problem, Rod. Very interested to hear other people's thoughts on that.
I think there was a question from Mike. Mike, do you want to ask it in person?
Sure. Thanks very much for your talk, Emma. Really enjoyed that. Just wondering, are all of the seagrasses that you're working in intertidal, or do you have subtidal as well? And therefore, how important is the light climate, especially in an obviously tidal area such as Gladstone?
Yeah, so all the Zostra that we get, because obviously Zostra is quite picky about its light, it likes a lot of it. So that's all intertidal, or most very few little patches that are subtidal. And then a lot of the subtidal meadows tend to be the halophilas. So the moment we're focusing on Zostra, but we're starting to also look at halogule as well, halogule uninervis. So yeah, so most of the meadows that we're looking at the moment are intertidal. I think that's an advantage, because I think some of the things that we're looking at with the seed dispersal can work by dispersing the seeds when it's low tide, and giving them, especially when the tide's just gone out, and giving them a chance to almost stick and stay put before the tide comes in. Whereas if you try and disperse them when the tide's in or in subtidal meadows, then you've got a lot more problems with currents moving things around. So one of the things we're looking at is getting them in almost like seed balls in like a clear material that keeps them together, so that when they'll go straight onto the seabed and they stay on the seabed. But basically looking through other methodologies for keeping them sticky. And if that was overcome, then it wouldn't be a problem for the subtidal meadows. But we're not at the moment working with the halophilas, just because of the size of the seeds and the difficulties with managing those seeds.
That's great, thank you.
I think Paul or Tamaya had a question as well. Paul, do you want to ask it in person, or? I'm just trying to get a conversation going. Hi, Paul.
Hello. I just wanted to ask you, Emma, you focus mainly on Zostra muelleri because it's mass-produced seeds. It's relatively easy to collect more material, of course. You noted there were other species as well in your study area. Of course, there were other parts of the world. We have many other seagrass species that don't necessarily always have that luxury of producing a lot of seeds that are readily available for restoration. So if you have any ideas or advice on how to upscale and move into larger scale restoration efforts with other species that don't have that seed availability, like
it's a really good question. Yeah, so that like I said that before, the halophilus, you know, the seeds are really tiny, but with the halophilus, I think one of the things that we looked at is the you know, just using fragments, but not, rather than going out and planting fragments of halophila, to actually just disperse fragments of halophila into an area, and again have the same issue of how do you get them to stay put. So we've run some trials in the tidal mesocosms that we have, and halophila is really quite amazing that even in one tidal cycle it can actually attach and start to like establish, like it can put the roots down and it can hold fast with the little like the globules it has and it's like roots. So there's potential there, I think, with the halophilus to just do it with fragments. It's then how you get those fragments, and I think you get those fragments by having nurseries where you're growing it en masse and then you're breaking up. You know, get an understanding of what sort of size you can break it, what fragments you can break it up to that are viable, and then going out and dispersing them as you would seeds. Halogel is a bit more of an issue because it's dioecious, and it's, I mean, I've been in Gladstone for 10 years now. I've never seen a seed. I didn't believe that halogel created seeds, and I never saw one in Gladstone until the JCU guys took me up to, the Seagrass Watch guys took me to Shoalwater and showed me what halogel seeds look like. And so I think there's a problem there, and I think maybe with that one we've got to try and look at, you know, what's happening with the population dynamics of halogel in the area. Even then, you know, they don't produce seeds in the quantities like you said that Zostra do, so there will be a challenge there. But with halogel moving like southwards, halogel moving southwards in terms of its dominance, and Zostra, you know, getting too hot for Zostra, it's definitely a species that we've got to try and focus more on. But yeah, it's a good question that I haven't got a great answer to, sorry.
I also have a comment. You asked about this creating new areas. You wanted more discussion on that.
Yeah.
So I'm involved in several of such initiatives for various different types of habitats, but also with seagrass now. And that also brings me to that issue of reuse of dredged material. There could be, I mean, it's always site specific, right? It depends on the location and the conditions. But with dredged material, depending on its composition, you could play around, if I may put it that way, sometimes to make unsuitable areas more suitable. For example, by making them maybe a bit shallower, so there's more light reaching the bottom. Or you could modify the composition of the surface layer of the sediment from very fine to what maybe somewhat more coarse, or the other way around. If it's too coarse, then maybe add some fines. It can also be like a top dressing kind of a layer of material to suppress bioturbators that constantly frustrate any attempts by seagrass to establish itself, because they keep pulling them out, you know. But if you top dress that with a layer of different type of material that could temporarily suppress bioturbators and can give the seagrasses a chance to establish or re-establish. And so there's lots of creative options with dredged material that we are testing, also to fill in scars and damaged holes from storms or boats or anchors or dredging or other things. So I'm working on some of that with people here in WA. So
we get to talk to you more about that, because we find it difficult in terms of the permitting, and for, you know, looking at it, there's a lot of like risk aversion here for sort of like doing things like that. it naturally where they've got the maintenance dredge spoil grounds here, like it's now slightly higher than the rest of the area, and they're getting the halophila is starting to grow on that. But we're also like working with the port on some of the options for living seawalls and creating seawalls in a way that can create areas where you can put dredge material and create seagrass meadows, and that might be a little bit easier because you're attaching it to an area that's already had the human disturbance of building a seawall. In other areas where, exact thing, you could raise the seabed slightly, because on those habitat suitability models, it's also useful to look at the unsuitable habitat and what's unsuitable about it, and then work out how you could make it suitable by putting in, maybe creating shelter from wave exposure, or like you said, increasing the depth by putting decreasing the depth by putting dredge material there. So I think there's a lot of opportunities, and we've got to somehow get through some of the red tape to be able to start to use these things. But the argument often is that there's nothing there. You've got an existing mud flat or something that's got a function or is a habitat, so you're replacing it with something else. But then you start the argument as to, okay, well, what functions are you losing by putting a seagrass meadow there instead? And then it gets a bit harder to justify. So, but yeah, it's still an argument.
Those options are the greatest. They have the greatest potential in the vicinity of ports, where there has been already a lot of disturbance and a lot of degraded habitats available, and areas that are currently not serving very high ecological functions. And then also to incorporate such ideas, such ways of thinking into the designs for port expansion or the creation of new ports, because that's when all the gadgets and big equipment and tools and money and decision makers are all available and sitting around the table, stakeholders are being engaged, and those are the opportunities where new things can be tested and implemented.
Yeah, definitely.
So I think relating to this discussion we have now, I think Laura had a question about whether you have the local support in terms of legal governance, community. Laura, are you around? Do you want to ask the question yourself?
Yeah, sure. So thanks, Emma. Very interesting talk. Very great holistic approaches Celia already emphasized. So I was wondering, indeed, whether you actually have support, like to plant seagrass or to restore seagrass in areas without any previous records. Because I think that's something we may all be struggling with, because, well, a lot of systems have changed so dramatically. And, well, I really enjoyed your arguments, but I was just wondering about your local situation there. Thanks.
Yeah, so like I said before, so there's an area that we proposed in terms of enhancement with dredge material to decrease the depth to get seagrass growing there. That one has got support by the local community and by the port operators, but hasn't got support by state government, just because of the issue with changing the use, or changing it from a mud flat to a seagrass meadow and putting sediment there. But then there's other opportunities, a bit like Paul was saying, where there's a bit more disturbed areas. So these disturbed areas that are already disturbed, they're not, even the sediment next to these seawalls isn't naturally what was there before. So in those areas, there's a lot of support for looking at opportunities to create it. What's needed though is you need to get those demonstration sites in, which is what we're doing at the moment, and get the demonstration sites in, show that it works on a smaller scale before you can get the funding, get it happening at a big scale, which is actually, I think, more probable that can happen with these seawall situations. But with those other bigger projects, bigger ideas for doing large scale shoaling or protection or large scale seeding, well, seeding's different, but large scale shoaling is much more difficult, because you need to do it at a big scale to have the effects in terms of overcoming things like the biostability and the success you get just by scaling up seagrass, but to actually try and prove that it would work at a smaller scale is really difficult. You can't cap a small area and have a really big impact in terms of stopping resuspension of fine sediments. So you need to almost do it at quite a large scale, and getting the permissions to do that is quite difficult. So yeah, good community support, good support by Glasgow Ports Corporation and others in the area, and good discussions with state government as well. But I think there's still a way to go there.
Thanks, Laura. So I think in relation, I want to ask a question to Emma. So in relation to this whole creating new seagrass areas for restoration efforts or creating new meadows, I think like when you visited Singapore in 2018 during the Seagrass conference, we visited some of these areas, where it happened to be a happy coincidence that there is restoration there. But when you speak about it in a more active sense, like what is the framework that you're thinking of? So is it like you're not only designing the coastline, but also like going in there with active restoration, or because I think what we found through Sam's PhD work was that these meadows that are recolonized tend to be lower in genetic diversity. So how do we manage the resilience aspects of these newly created habitats?
Yeah, it's a really good question. I think it comes down to like those elements that were in Richard's summary image. So, getting all of those elements in place. So it's not just a case of creating suitable habitat for seagrass and either letting it naturally recolonize or just transplanting a few seagrasses in and letting it spread. It's actually thinking about the connectivity with other habitats. It's thinking about the having that diversity of species in different areas, having just diversity in terms of the configuration of the meadows as well, and that genetic diversity. And there's a lot to be learned from terrestrial systems with sea-based restoration in terms of understanding how to make sure that you get that genetic diversity when you're using your seeds, and about looking at adaptation and which seeds from which populations and the different proportions to use in different situations. So I think if we're creating seagrass and doing it in a way, there's a lot of opportunities there to do it in a way that creates resilience. So making sure we put seagrass into those areas that are really well connected as potential sources of propagules for other meadows within an area is a really key one.
Okay. So there's actually a lot of planning involved in this, like, in this whole thing, right? So it's not just about the creation of the area, but it's also understanding, like you said, all those factors that contribute to the resilience, and then like what species might potentially be thriving there or not.
Yeah, definitely. And it might be a step-based process. So, the first step is to just work out if you can get suitable habitat there for seagrasses to grow, and then start to think about those other things. But definitely in terms of location, considering the connectivity with other meadows and other habitats is going to be important from both a resilience point of view, but also in terms of the functioning of the meadow.
Cool. Okay, so I think we have time for one last question, if everyone's okay with that. It comes from Shubin, who asked, what seagrass species are the most affected because of flood events in your study, I think?
Yeah, so I think it's a difficult one to answer because, a lot of the Lophilas can get like ripped up and taken away and die off, but they come back really quickly because they recover really fast. The one that's the most sensitive to light is the Zostra muelleri. So that one does get really badly affected by flood events because of the turbidity of the water and the burial that happens after the flood event. So when all these fine sediments start to settle out and basically smother the seagrass, it's not getting enough light. And then the halogule is less sensitive to that. It can cope with being buried quite a lot and can screw up out through it. We've found halogule that's growing up from the roots rhizomes are at a depth of about 30 centimeters, and they're basically grown up through the sediment as the sediments shift around, but can of course get affected by the flood events because they need that light. So if it's really prolonged, then it could be a problem for them as well.
Okay, well, I think we've come to the end of that. Please, everyone, thank me in joining Emma for that wonderful talk. It's very, very informative, and thank you everybody for joining us. I think look forward to our next Seagrass seminar series, and yeah, thanks everyone. If you have any other questions, Emma, I'm sure will be happy to pick that up, separately. So you can email her. I think you'll be able to find her email online quite easily. So please continue this conversation on seagrass restoration. It's a very.
It was on the last slide that I just removed the share of, but yeah, hopefully people got it.
Thanks again, Emma, and thank you everybody.
Thank you, everyone. Thanks all for coming along. All right.
Thank you.
Hopefully see you soon at ISBW.
Yes, at ISBW. keep a lookout for that. Thanks,
Okay.
everyone.
Bye.
Bye.
Thanks, CT.
Well,
Thanks, Emma.